So, what if we, there's got to be something that, so you were mentioning making an IQ modulator for AM, and you also mentioned you wanted to be able to put your call sign up over the waterfall. So I'm just trying to think of a way that that could be done. Technically would be a single sideband emission on top of your AM emission, so you would lose some headroom. But, oh yeah, you cut down your AM carrier to half power, and you do amplitude modulation, and then over top of that you have a some sort of a incremental counter which looks at the font of your call sign and then plots that out in the Fourier space, and then sums up all the frequencies and then keeps it within the ALC of your amplifier. It would be completely linear, and you would be able to put your ID out over top of your AM carrier. Either that, or you could just accept that on the one sideband it's going to be out of it's going to be a mirror image. Maybe you want that. That'd be a cool effect. KC3FKR.
Why not do independent sideband?
Well, that's the other thing. But Dan, I think you could do it with the mirrored on the the other sideband effect if you compensated that for that with your image, like draw half of the image and send that, and as long as it was like inverted, it would complete the rest of the image on the other sideband, but you'd have to make sure it did that.
Well, your font would have to be symmetrical for every letter. I like Clark's idea. You just have a little sideband up a couple kilohertz above your upper sideband of your AM carrier that has your little call sign, or you just play it when you're on peg.
Well, you can always replicate the independent sideband AM stereo system.
Well, yeah, that's just all that really is just upper lower sideband with an injected carrier. So that's exactly what you're doing with the SDR.
And isn't that amazing? They were doing that in the 50s. N1BCG.
Yeah, that's one of the cooler things that I've ever ran into. The C-QUAM is what came after that, right? How does the C-QUAM work?
The C-QUAM is quadrature. That's where they've got the carrier phase modulated. I actually have, sitting on the floor of my kitchen, well, long story, a Motorola C-QUAM AM stereo generator. And so you feed your left and right analog audio into it, and it takes the left and right, sums them, and feeds that out in a single balanced output to the modulator of the transmitter. And then it takes the left minus right and feeds that into a phase modulator. So it actually takes the carrier and phase modulates that, and then the receiver sorts it back out again. Motorola came up with that because Leonard Kahn had the independent sideband system. This is going back to the 80s when AM stereo was coming of itself, and he used the independent sidebands, which were obviously the most bulletproof when it comes to fading and propagation and co-channel interference and all. It made the most sense. You could even use two radios to tune it in. It was sort of very rough, but it was an easy demonstration to do that. But Motorola wanted to get into the business, and they had big cash and good lawyers. So their task was, okay, we want in on this AM stereo thing, but Kahn's got a patent on the independent sideband, so we need to do AM stereo and not that. So that's when they came up with the quadrature system. C-QUAM, AM, oh my God. What the hell call sign am I supposed to give here? N1BCG.
Well, that's I've actually never looked into how C-QUAM worked, but that's a really good explanation, and that makes sense to me. So you have a superposition of amplitude modulation such that it's backwards compatible with all sorts of old school AM receivers, and then you just have that phase component in there, which you can just decode with quadrature methods, or even more simply, you do a PLL and you just ride the error voltage there, and that forms your left channel or your right channel, what have you. So that's really interesting, and then you can sort out each channel by just looking at the sum and difference of the amplitude modulated signal and the phase modulated signal. Motorola and their cleverness. It just surprises me sometimes with the stuff that I hear, because I look at, some of the cutting edge technology on digital communications and carrier generation for signals that are way up there, 40, 50 gigahertz. But then I look back at stuff like C-QUAM and I'm like, that's really clever. KC3FKR.
You would probably really like to see the history of AM stereo, because there are a lot of good websites that describe the Con system, the Motorola system, the Magnavox system, and the Harris system. So there were 4, I believe, unless I'm leaving one out. I think there were 4. And Harris and Magnavox ended up dropping out, and the real battle was between Con and Motorola. The radio station here, my first job out of college was to take the local AM station and make it stereo, and I ended up getting the Motorola C-QUAM format, which is how I'm familiar with that, because I actually got to put it in. But it's very time delay sensitive. They had Gates BC1G transmitters. So part of the key of maintaining your stereo separation and flat bandwidth is having a very stable transmitter. Well, it's very hard to do that with 833s that vary in their performance with time. So it was weekly Sunday night trips to the transmitter to readjust the phasing and the delays and all that. So it was quite a thing. But you know what? For 1986 and 87, it was totally normal.
Well, yeah. Also, the modulator, got some phase shift there in the modulator. That would introduce some artifacts. Yeah, KC3FKR.
Why'd they have to C-QUAM everything? ISB is for me.
Right, that was the argument, and it should have been like that, because it was the obvious, easy system. The whole thing with AM stereo is it had to be backward compatible. I mean, no system was going to get approved if you had to have a separate radio for it. So basically, whatever you did had to sound totally normal on an existing receiver. The Con system did, because if you tuned in the station, the receiver would be receiving the upper and the lower sidebands equally well, and it would just mono itself.
The hell is that?
By the way it works. And that system had been around for decades. That's even by the 80s it had been around for decades. But the Motorola system was, okay, well, we know we've got to feed left plus right into the modulator, so what does that leave? And that's when they started putting their attention towards the carrier. AM broadcast stations have to maintain a average oscillator frequency tolerance of plus or minus 20 hertz. So as long as they stayed within that, even with the FMing or PMing in this case, then that was considered legal. So it's a fascinating thing. And yes, Daniel, the phase shifts within the modulator, that's why if you look inside these stereo exciters, you've got banks of multi-turn trim pots which will affect delay and phase for the various bands throughout the audio spectrum, and that's for the left and the right channel. So it was really something to do the performances where you're running frequency response tests on the radio stations, and not only just the frequency response for mono, but the frequency response for both the left plus right, left minus right, left only, and right only, N1BCG.
Jeez.
Yeah, so if you had an old school, like you said, you had a BC1G at the radio station you were running, KC3FKR. If you had one of those old school transmitters, obviously you're phase modulating the carrier going into the first buffer. Did that introduce any form of nonlinearities in the finals? I mean, as you center, so you had plus or minus 20 hertz as your deviation. So obviously that won't cause any detuning. But what was the overall bandwidth of that? I mean, with 20 hertz of deviation, must have had an insanely good PLL to do decoding on that N1BCG in their group with W2BTK KC3FKR.
Well, actually, one of the big challenges was the load on the transmitter, because you had to make sure that the PA stage didn't see asymmetric loading, as because it wasn't the oscillator frequency switch. Oh, and by the way, the oscillator was replaced by the stereo generator, so the stereo exciter had its own oscillator in it, because it wasn't something like you had to hook something up to the transmitter's oscillator. You replaced it. So the oscillator module was taken out of the BC1G and just set aside. But getting back to the PA, this is a really interesting discussion. The load had to be symmetric, so no more could you say, well, the antenna is about the right impedance, but the transmitter's output tuning circuit makes up for it. And you actually had to have the proper reactance for both 1, 5, and 10 kilohertz up and 1, 5, and 10 kilohertz down. So we ended up broadbanding even the antenna for AM stereo. It was a 150-foot tall self-supporting tower, which was 20 feet across at the base, which is still pretty broadband. And even then, we ended up adding a skirt to it. So we had we made it into a monopole with the feed line, were now the steel cables, which were hung 3 feet off the 4 corners of the tower. And the new feed point was a ring, which was about 12 feet above the ground, which went and connected the 4 feed lines that went up the tower. So the width, the bandwidth now went from being that of a self-supporting tower to now being a self-supporting tower plus the feed lines on the 4 corners. So broad-bandedness on the load and having a symmetric load above and below the carrier ended up being very important.
Jeez. Yeah, I would expect that there, but so if you're running a 20-foot diameter tower, so correct me, I didn't follow you there. I understand that the C-QUAM signal was being generated in tandem with the modulation. It was all the actual generator was going to feed the buffer. So we take out the oscillator. Now we're down to the plus or minus 20 hertz deviation. Why would the antenna network have to be resonant or matched correctly for, I guess, plus or minus 10 kilohertz, unless you're using some insanely high modulation index?
Oh, I see what. Okay, now I realize where the disconnect is. Think of it as an FM broadcast station. Here, FM broadcast stations also have a very narrow tolerance as far as what their average carrier frequency is. But because the carrier is in FM broadcasting, it's being modulated 75 kilohertz. That's way beyond the frequency tolerance, but the FCC says this is your average frequency tolerance, not your instantaneous frequency tolerance. And it's the same thing for AM. If there's no modulation, no left plus right, no left minus right, no left or right independently, that carrier needs to be sitting within 20 cycles of either above or below the assigned frequency of the station. But when it's being modulated, then it's fine. Then it can go far beyond that. That's where the disconnect is.
Oh, okay. So you're using a wider FM modulation. I thought you were using something like a 20 hertz wide deviation. I was like, well, that's got to be some insanely good signal-to-noise ratio to actually get decent bandwidth out of that. Yes, that makes sense. Got, well, let's see, we can approximate that relationship using, get the Nyquist-Shannon data bandwidth relation. So if you got to shrink your bandwidth, you got to have either low data rates or lower signal-noise ratio. So interesting stuff. I've never actually looked into that, but the C-QUAM method seems quite complex, and I can see why it isn't used today.
And remember, you had 20 kilohertz of bandwidth to work with.
Well, there you go. So I guess you can stick your carrier in the middle there and deviate plus or minus 10. No, you can't, because your sidebands move with your carrier. So that's a really complicated function there to look at, because you have amplitude modulation and phase modulation. So you have the Jacobi-Anger expansion to represent the to represent all the different frequencies in that FM signal, and then you have on top of that the convolution of your amplitude modulation onto the carrier, and the sum of that represents the total signal spectrum. So that's just some crazy stuff.
Yeah, but also keep in mind that it is rare that you'd have 100% single channel modulation. Like, you'd never have 100% different signal being transmitted. It's the left minus right is actually not a very high level of modulation compared to left plus right. So it doesn't take much to create a good stereo image. And the system did have left minus right, a separate left minus right limiter to prevent it from getting crazy. So your actual stereo separation was limited due to, practical reasons. But for all intents and purposes, if you look at most music, you rarely see 100% separation. Now, there are very few cases, like some of the older Beatles songs, where they would have all their music in one channel and all their vocals in the other. You're talking insane amounts of separation at that point. But most music, and Billy knows this, most music is not that stereo. There may be mid-range and highs which have some stereo effect to it, some reverb and things like that will have some left minus right to it, but like a lot of the lower frequencies, bass and stuff, it's mostly mono.
Yeah, in general, vocals, kick drums, bass guitars, snare drums, right down the middle. Then you can there's also mid-side, and I don't know if that comes in to broadcast stuff. That's not really my bailiwick, I'm just a digital audio guy.
The bailiwick?
Well, it's like a subwoofer, really. That's just mono, really. It's mono. That I understand. But Clark, that's a very interesting conversation about the C-QUAM. I've heard about it. Didn't really know much about it, but now I know a hell of a lot. KC2DHU.
Daniel knows that word, bailiwick. We learned that together the other day from Paul VJB.
Ah, yes. Paul and his vocabulary.
The bailiwick. I don't know that I have ever used that word in any form of real context, but at least now I know the bailiwick. So I wonder if you could do straight out, if you were to take the C-QUAM method, which is really just QUAM, and you decompose your IQ signals into a phase component, so you take the inverse tangent of I and Q out of your fancy whatchamahave SDR. So you take that and you compose an angle for that signal, for that phase that you want to do. And you generate a phase component on your modulator inside of your plate modulated transmitter. And then you take your amplitude component out of your complex magnitude of I and Q. And this can all be done in digital signal processing. So you pipe that into your plate modulated AM transmitter, and bada bing, bada boom, you now have a quasi SDR controlled plate modulated transmitter. This has me thinking now. Clark, this is not good. Giving me ideas is not a good idea.
You know, there are chips, just regular chips, I think 14-pin chips that will do C-QUAM transmission. There's a C-QUAM AM Part 15 transmitter kit you can buy for $130 from, who is it, Sean Cuthbert. Or no, maybe it's not it's around $130. Maybe it's $150 for C-QUAM. But it's like, holy crap, you know, it's so simple now. Whereas if you look at the stuff that I've got here from the radio station, it's, you know, it's 3 rack units high, and it costs like $8,000. You know, you take off the back plate of it, and it's just got slide-in card after slide-in card. I think there's like 9 cards all in a row, not including the power supply. And it was all done analog with discrete components. Now, you can, like I said, you can build an AM transmitter kit for you know, 100 and whatever it is dollars, which does C-QUAM. So the technology has most certainly evolved quite a bit since the 80s when it came out. N1BCG.
Well, yeah, what I'm talking about is actually taking the concept of using C-QUAM and sort of backfeeding it with an SDR, such that you can actually generate an arbitrary waveform out of a plate modulated transmitter. Mind you, there's some inherent flaws with that, such as carrier rejection. That would be impossible. But if you wanted to do wideband data, like if you wanted to do DRM, you could do that. I don't know how wide DRM is, but you could probably make a standard plate modulated transmitter into a DRM transmitter just using QUAM. Generate a QPSK signal. That would be very easy. But then you can generate an N-level digitally modulated signal by just varying the carrier power along with the phase of the exciter. That wouldn't be too terribly difficult to do. So, you're giving me ideas. Maybe this is something I'll play around with, see if I can't make this transmitter do 16 QUAM data transmissions, KC3FKR.
Dude, that's next level. That's crazy.
Challenges.
I wonder if I can get this Harvey Wells to transmit AM stereo.
Well, evidently it wouldn't be too difficult. Clark, what did you say you had a double there with Billy?
I said linearity and broadbandedness are going to be the biggest challenges.
Yeah, I agree. That would be the main problem that you would have. So you would really be limited to something with an instantaneous bandwidth that's about as wide as one sideband. And in terms of linearity, you might be able to do some compensation for that in software.
You really think you could just make any arbitrary waveform with like the plate modulated setup? That I'm still thinking about it. Like I'm trying to catch up.
No, you couldn't make any asterisk arbitrary waveform, but there are some you could do. It works on the same principle as C-QUAM would. I've never thought about it that way, but there might be some way to do some sort of higher level modulation. I'd have to do some simulations in MATLAB or something.
Dude, that's really crazy stuff. Like, that's uncharted. I don't hear anybody talking about that. I've never heard somebody say the things you just said. That's really cool.
Well, you just heard Clark talking about it. Clark's big braining in here.
No, but you know what? There's a guy, there's a ham radio operator that actually used to transmit in C-QUAM. I'm going to try to find out who it is. He has a fascinating, actually, yes. Let me try to find him because he's got a whole write-up on his C-QUAM on ham radio, and I think you guys would really find it very interesting. I'll be back. N1BCG.
KC3FKR for legal station identification.
I just want plate modulated ISB. W2BTK.
KD2AFL.
And there's the T368.
Oh yeah, the glass from the past.
Let's see, are you putting any holes in the clouds up there, Daryl?
Nah, not yet. How you doing this evening?
We're talking about doing some big brain stuff. Maybe it's... That would be so interesting if there was a way that you could convert a plate modulated transmitter into a digital modulation scheme of some sort. Obviously they do that, but some sort of very standardized audio format, such that somebody with an SDR program on the other end could decode your audio, and with some compression you could have basically all the bandwidth you want in terms of audio.
That'd be real cool, especially for this old transmitter. Wow. That'd be real good.
Well, Clark was talking about doing that kind of analog just with like pitch shifting, really. You would I forget how he explained it. It made perfect sense. Like you would transmit your audio at like a higher pitch or a lower pitch, I forget which way it worked, but then, you know, the other person would bring it back down and you could transmit with more bandwidth but take up less bandwidth.
You sort of like segment your data there, so you speed up your audio and then slow it down at the receiver, something like that.
Yeah, that's how it was working. Is pitch it like way up in frequency, transmit it, and then bring it back down at the receiver.
Yeah, that could theoretically work, I suppose. There's a lot of interesting things that could come out of this. I mean, a lot of us are in here with the very traditional method of AM, which is certainly fun to play with. But I'm just, the gears are wearing here, and I'm wondering if there's some weird digital mode that we could do with our transmitters. I don't know. It's mathematically possible, but in practicality, I think there might be some limiting factors. I have to do some simulations. Basically, just be manifesting a MATLAB program that takes in some INQ data and applies element-wise phase shifts and amplitude shifts. And the only problem is that in a standard vector modulator, you don't have a steady-state carrier. The carrier is only there when you want it there. And the carrier magnitude can be flipped 180 degrees. So if you want to do a 180 degrees carrier shift, you actually have to think about that and flip the phase of your exciter. So there's going to be some like range of values that you can't operate in the unit circle. So I have to play around with that. This has me intrigued. I could be barking up a false tree, though. I don't really know what to believe. Taking all these math classes, it makes me think that things are possible from any angle, but you have to take a look at the practicalities of things. KC3FKR in Newark, Delaware, remote control.
Yeah, it's... I wouldn't know. I'm not that... It would take me a while to catch up to where you are, and then you got to do some research to see if it's even feasible. But I still think it's a cool idea.
Yeah, so just imagine being able to hop on and transmit your voice over digital through your Johnson Valiant.
Seems like sacrilege.
Tisk tisk.
Yeah, I know. I own one, but still.
It's the future. Here we are.
I wish I had echo so I could go future, 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 future.
Can't find that call sign of the guy who did C-QUAM. He's it was a great web. You know what? If I can't find it during this QSO, I'll email you guys. I will find it eventually.
Uh-oh. So if he did C-QUAM, then we just need to do QUAM.
No way. Plate modulated ISB.
Well, I guess that's how phasing modulators work. In the phasing rigs, I mean, they would do that. You get phase and you get sideband cancellation. Problem is that you would have a carrier component there that you could never get rid of.
Yeah, we can we could still talk about it.
Slop bucket on AM.
I found it. It's WA2FNQ Foxtrot November Quebec.com. Yep. There it is. Talks all about AM stereo. WA2FNQ.com.
I'm going to be looking this up, and I'm going to commentate right now. Here we go. We have, packets. He does fast scan television. Oh, here's AM stereo on 75 meter. Oh, wow, that is quite a write-up. I won't be commentating this.
I feel like it.
Let's see here. Yep. Okay, so he's using a Constat Super 6 converter ahead of the Radio Shack TN152 AM stereos. Oh, so he's doing some receive there. I wonder how many people he had in his posse that were using his setup on their transmitter.
Well, the problem with that system, again, from personal experience, is that if you listen to a C-QUAM AM transmission when there's co-channel interference, so you've got other stations like on the broadcast band, because all the radio stations were such close tolerance and frequencies, the beat would be very low. And if you listen to AM stereo at night and you had co-channel interference, the stereo image would shift between the left and the right channels at the same rate that the stations were off frequency by. So if you were listening to music, it would, as the interfering signal would beat with the signal you're listening to, the emphasis would switch from left channel to right channel to left channel to right channel, and it gave this sort of like spinning around in your head effect. So AM stereo at night was well, for lack of a better term, a mess.
Well, who wouldn't want that? It's just like a wireless rotary speaker. If you play organ, you have a wireless Leslie.
A wireless Leslie?
Not quite. You don't get the Doppler shift.
Now the other problem is.
Hey Rob, thanks for the follow, man.
The pilot light to indicate to the receivers that, hey, you should be switching into stereo mode was 25 cycles. So all the radio stations that went into stereo had to get rid of all their audio. It had to be basically gone by 25 cycles, so that carrier, well, that tone could be there to do the triggering, and of course to light up all those, hey, this is in stereo light.
Yeah, I guess that would be a limiting factor on the lower end bandwidth, but I wonder how many people's AM stereo receivers actually received down below 20 cycles in terms of audio back then.
Not many, but Radio Shack sold a AM stereo tuner. It was amazing. I've got one, and I remember that it had such lousy low-end frequency response, and the reason was all in bad coupling caps. And I remember going in there and beefing them up. And they had like 0.5 microfarad discs, and I'd put in 4.7 microfarad electrolytics and really beefed it up. But not to the point where you're from the stereo pilot. But they were way too conservative with their low end, and that ended up being an amazing sounding tuner. Those things go for good cash on eBay these days.
Speaking of Radio Shack, Clark, have you ever written down or documented all the crap you did to your little receiver?
Yeah, that I just talked about?
Yeah.
Yes. In fact, it was just a couple of months ago that I actually found notes on that from the late 80s.
That thing's all tricked out, right?
Oh, it sounds like $1 million. The only downside of it is that when you tune across stations that are stereo, which of course is rare now, when the system switches in and out of stereo, there's a pop. So if you listen to it on big speakers and stuff like that, it's jarring. But if the key to that is if you leave it set to mono and you do your tuning around, and then you find the station you want to listen to, and then you turn on you switch it to stereo, it's okay. It's just when you tune past stations, it creates that burst.
And that's it. I'm talking about the receiver you're listening on right now, too.
Oh, oops. Yes, the DX160. That also is very well documented.
What? You have it up somewhere where people can see it?
I don't know, but I mean, if you're interested, I'll just email it to you. It's the main thing is changing the components around the audio amplifier to what they should be per the chip manufacturer, and then making some changes to the power supply.
Those DX160s, how much do those usually go for? Because I'm looking to get a play around receiver to listen to, because in the shack I only have a IC7300, which has excellent high ends, but absolutely zero low end for some reason.
The DX160 will have absolutely no low end also, and that's one of the reasons why I did the mods. But there are a lot of good tabletop portables. Sangean makes a lot of, some of the older Sangeans are very good with that. So I don't know if you know, what kind of a radio you want and how much space you want it to take up. But I mean, I really like this DX160. I've had it now for 30, what is it, 43 years now. I've been using this radio.
Yeah, see, the other option that I would rather pursue is I have a DX170. That is the exact opposite problem. It's got plenty of low end, but it's got zero high end. And that's due to the crystal filter. So I was going to design a 10 kilohertz wide tap to put on that filter so that I could basically just disable the crystal filter and run a high fidelity AM signal through the IF, which is actually, if I remember correctly, 60 kilohertz, really low IF. So I would like to get that working if I could with a little bit better fidelity. Thing needs an alignment anyway. KC3FKR.
You know, you can always just put a resistor across the crystal filter so some of the frequencies are bypassed, and then the value of that resistor will determine how many highs you have.
Yeah, that too.
Well, that's kind of the poor man's way of fixing it.
Inverse, sort of like an inverse NRC curve. Or, sorry, that's not the inverse NRC curve. You apply like a steeper NRC curve, but coming into the receiver.
You know, my boss for 10 years at the radio stations here in Connecticut was on that board, the NRSC board. So every time we went to the NAB conventions, National Association of Broadcasters conventions, he would be speaking about that stuff. And of course, I had to go to those presentations and sit through the 3 hours of it. And at the end, tell him what a great job he did. But it's just like, I'm not interested in this stuff. But it's when it's your boss, you kind of have to go.
Yeah, I wouldn't want to upset the boss, especially if he's on the NRSC board.
It's getting a little splashy around here. Louis just said he's going to fire up on 3880 with the big rig. He gave me fair warning in the chat. 5 minutes.
The large rig?
Who's Louis?
Oh, you know, N1 GTO.
Oh, my fan club.
Why doesn't he just move up here and join us? Or maybe he's talking to somebody down or out west.
Well, he was listening to us for a while here in the chat, I think. But he's going to fire up, yeah, with everybody out there in Nine Land and out there on 3880. So, I don't know, we'll see what the band is doing tonight. Might not be an issue. I know I've got an SDR receiver, so I can just kind of make stuff go away. And that's the thing, man, that DX160, you must get, like, headaches, man. You can't really... You can listen off to the side and stuff, but when it really gets crazy, I mean, what do you do? Get off the air.
Exactly.
I know, and there's all these posts about vintage receivers and stuff. Vintage receivers are awesome. Some of them sound great, but everybody's poo-pooing the SDR stuff, and I think that it's like a huge step forward in receiver technology. I mean, the things I can do with this SDR... It's just, it's more effective than anything else I've ever used.
I think the argument is in audio quality, in terms of bit depth. Like if you're using an RTL SDR dongle, you only have 8 bits on I and Q, so it doesn't afford you as much dynamic range as something with analog demodulation would. If you want to get a flex though, that's a different story.
Yeah.
My issue is actually much simpler than that. I spend all day for work staring at computer monitors. So when that day is done and I'm trying to do this stuff, Last thing I want to do is see, get it, more computer monitors.
Yeah. When I was, I do the same thing because I was, this summer I was working on a project for work. And my assignment on the project was to design this optical processing board, and I had photodiodes and translinear logarithmic amplifiers and microcontrollers and all sorts of different crazy stuff on this board, and I was staring at a computer screen and spending my entire day looking at data sheets, and I'd come home at the end of the day and I'd try to do something technical for ham radio, and I would just be fried, for lack of a better word. So that is a thing. I'm with you there on that, Clark. KC3FKR remote control.
Wow. I've got what do I've got? Yeah, I've got 20 dB of attenuation in line with my receiver, and some of those S's and T's from down the bin are getting way out there. Doesn't seem, well, I don't know, it's not bothering me, I'm just making an observation. That's pretty intense. I'm not gonna lie. W2BTK on Montana Mountain.
Well, I guess Clark is away from the station there. This is KC3FKR. Well, I'm getting all talked out, but it was interesting talking to you guys about all the different QUAM stuff, C-QUAM, AM stereo. That's the stuff I like to talk about on here. Finding some guys and talking about something technical. Especially Clark, you got him in there. His broadcast knowledge wealth, so that's always a benefit, I guess we'll put it that way. So I don't get on the radio as often as I had before when I was in high school, but now that all this coronavirus stuff is going on, I've gotten on a lot more, but a lot of times I come on here and I intend on hopping on and talking to you guys, but I come on and everyone's talking about coronavirus, and I'm like, I don't want to talk about coronavirus. But this was a really good conversation, and Clark, thanks for bringing up the AM stereo stuff. That was awesome. KC3FKR.
Yes, Clark, that was awesome, I have to say, and I don't say that often.
No, he sure doesn't.
Wow, look at that, and it's documented. But and Daniel, when you come out here, it kind of like, you know, I enjoy it, man, because it's always something technical, very interesting, and exactly, I don't want to talk about coronavirus and bitch about Democrats and stuff. I do that on the phone with my friends, you know, but it's really nice. Hey, Troy, thanks for the follow. Just awesome. I agree. Conversation was great. I enjoyed listening to it, and welcome back, Dave.
How is the shower radio?
It sounds really good. You were talking about the Sanjian, Clark, and compatible quadrature modulation. I was scrubbing my armpits during that. You know, like those commercials with the guy with the Irish Spring, but I don't have Irish Spring. I use basic soap with no, well, you don't need to know all about that. But anyway, yes, it was excellent, and I'm really happy I replaced my shower radio with this thing, because it sounds pretty good. Although it's supposed to run on 9 volts, I've got it running on 12 volts, and I blew one of those up, oh man, back in 1988, where I was working. I had it on 10 meter AM, and KH6CC from Hawaii came on, and he was really loud, and it blew up the audio amp because it was turned up really loud before I could get to it. So I'm going to try not to do that again with you guys. So I'm only 4 feet away from the radio now instead of 100 feet away like I was back then. You did ask.
Do you have just 12-volt power run into your shower?
I could send you pictures of what's running into my shower, and it's like, there's something really wrong with me mentally, and there's all kinds of things going on there.
Dave, that's an electrocution hazard. I don't want to read an obituary and where it says cause of death. Radio shower.
That AC/DC tube receiver, that's a no-no.
I got hit off of one of those. My dad had a 1939 Emerson, and when I was a kid, the on-off volume pot crapped out, and I replaced it with a Radio Shack one that didn't have the notch, so it had this bare shaft sticking out the front of it. And one day, yes, I grabbed a hold of it to turn down Rambling with Gambling or whatever the hell was going on. It was in the bathroom, and there was a connection. We won't get into the details, but anyway, I got the full current of that through the bypass to the chassis, which was, I still haven't forgotten that.
So just reverse the plug.
Neutral safety.
That'll teach you to turn the gamblings down.
Yes, yeah. Mm-hmm. Well, 2 of them are gone, and there's one that I don't know what he's doing.
So, if you have 12 volts running into your shower, hear me out. I'm thinking here, a good idea for you. Put your entire shack in the shower.
I would do that if I were alone and didn't have anybody else who could have input upon the dimensions and the equipment in the shower. Yes, but it's already built, number one, and number two, I had input from the XYL, and yeah, she really likes the ham radio stuff. It's on the first floor here in the front of the house with the wonderful looking room and all that, which she did the layout on. But the shower, I think, would have been a little over the top.
Dave, we'll do it over here at the BTK Bachelor Pad. Yeah.
No, better yet, just run a studio transmitter link to the shower.
I
There you
do with that, having done it for a living for a dozen years. I'm done with that. Thank you, and have a nice day.
Oh, what's wrong with 960 megs in the shower?
It'll cause cancer, don't you know?
No, Class E causes cancer.
You know, indirectly, I think it does. I mean, statistically, if you look, I mean, I'm just saying raw statistics. Man, there's a lot of people that land up with that. I don't know if the feds crack and the smoke comes out and you breathe it. I don't know what it is. Or heat sink compound. There's something going on there, man. There's a definite link.
It's if you scratch the printing off of the FETs. That's what's bad.
Well then, just build tube rigs, never build solid state stuff.
There you go, Daniel.
I think that was what he was trying to get somebody to say, so good.
I said it, and it was said. KC3FKR.
Yeah, you guys needed a time.
Anyways,
What you didn't ask for.
this is it. I think, was I doubling someone?
Yes, you were.
So we missed your ID.
Sorry, the station that was breaking in is KC3FKR. Sorry if I doubled on top of you. I don't know, I don't hear him anymore. KC3FKR. Anyway. Well, it was a pleasure talking to you gentlemen tonight, and I hope you guys are all well and good through all this, and enjoyed the conversations. And Dave, don't get electrocuted in the shower. Billy, I'll let you know if I can do digital QUAM modulation with a Johnson Valiant. and Clark. Don't read too much into the NRSC bandwidth limiting curves. That'll give you a headache. KC3FKR 73s, everybody. I'll see everyone later.
Always great to have you on the air.
Yes, see you later, Daniel. Thanks for stopping by, man. It's always a pleasure. W2BTK.
Good night, Daniel. Great banter, but don't get Clark started on rules and regulations, for crying out loud, man.
Started something.
Trying to.
Dave, that was you. You were in there with Daniel. It must have been. He got you, man.
Oh, well, you know, that happens. Daniel knows what he's doing, and I mean, I don't care who you are. You could be Dale Earnhardt, you know, once in a while. You need more than just a middle finger to get by.
I could tell, because we're all transmitting on different frequencies, except for Clark and Daniel. They're pretty tight on 85.
Let me go fix that.
You didn't get the memo about spread spectrum.
You know, I'm still here listening, but whenever somebody with a strong carrier keys up, it intermods with some shortwave station, and it's hilarious.
I've never heard of hilarious shortwave station. All right, I turned my Variac up, Billy. How's that?
Ooh. Yeah. You got a signal here, that's for sure.
QSC. Let's see. It likes this.
You're getting out there pretty good. I got 20 dB of attenuation in here. You had energy down to up to past 3895 on a couple of those S's right after you turned it up, and then it seemed to clean up a little bit, or you were talking a little bit differently, but seeing a little overshoot, and I'm pretty sure it's not my receiver. I mean, I've got the same thing going on, but I guess you just had that much signal on it that I was seeing some of that crap that was like way down is in there.
Yeah, you're doing the right thing having an attenuator on the receiver and seeing if everything looks the same, only less. That's the way to do it. And if you stick the attenuator in there and you see the same thing going on and it's on this end, yeah, might have something to do with contesting.
Yeah, I feel that, but I mean, I don't care. That was a big change, though. You went with the Variac. You're doing stuff. Hello.
I got a couple of more volts going here. I'm thinking a couple of more Penlight batteries in series. I really wouldn't want to be a 4-400 if I had the choice.
So it's now what, 12 volts instead of 9?
Remind me to not let you around my Collins 20V3. I don't want my 4-400s getting broken.
Well, if you're really, really careful with them, it's just amazing.
We had a 20V3 as a backup on 1350.
Did you let Dave put a Penlight battery in it?
No, the irony is that transmitter was supposed to be coming to my house for free because the stations were going to go to HD, and then they decided not to, and that's only after I spent a month cleaning it up and making it all, Clark ready, and then they said, hey, we got some great news, you don't have to worry about getting rid of the transmitter. Oh, that's awesome.
W2VW at 50, because you guys don't know when to ID.
W2BTK.
IDing. I don't have to say it at all, but I do anyway just to appease the great unwashed. That's you guys.
It's Clark's Book on Part 97. Send before midnight tonight and get an extra copy of Clark's Views on Life.
It is interesting.
Well, now that I've legally identified KC3FKR, those were my last peanut gallery comments. I don't want to overstay my welcome. This is KC3FKR. You guys take care tonight.
Oh no, you have a long way to go before you catch up with Connor.
You're the future of ham radio. You'll never overstay your welcome.
We'll see what the future brings. 73's KC3FKR. I'm gonna go QRT. Can't wait to unkey this transmitter, dude. The main contactor I put in this thing, it's like listening.
Hey,
to,
Caster, welcome. Thanks
like,
for the follow, man.
It's like music to my ears.
By the way, Connor, just kidding, but go to bed.
Yeah, no more Gene Shepard for you.
Or Gene Rayburn.
Yeah, remember Gene Rayburn on TV with those really long microphones? What was up with that? It was made out of telescoping antenna.
Yeah, those were early social distancing microphones.
Yeah, I guess somebody mandated that you had to close talk the mic, whatever the element was in there, you know. You got to put the mic right near your lips. But you can hold it down here. It's going to be new for the 70s. It's not even turbo yet, and it's way ahead of digital.
You know what? I think I'm going to identify myself from now on as N1BCG 74.
Oh, yeah, or 77, yeah. You know, this is digital W2VW.
Man, well, if somebody who's not a ham who likes to play with radios just wandered onto the frequency and was listening to us right now, what would you want to say to that person? I'll leave that open, but I'm really kind of looking towards Clark with this W2BTK.
I would say that hum you hear on Bill's carrier is his C-QUAM subcarrier. It causes the stereo light to come on your radio.
I was yelling at my receiver going, FNQ, FNQ, while you were doing that. So, WA2FNQ, I forget the other guy. The two of these guys used to get on every Sunday, and they might still get on down 30, somewhere lower in the band. They moved when the band expanded, so I don't remember, but Timmy could tell you. Timmy remembers everything. Anyway, those guys get on every Sunday and talk to each other, and the C-QUAM thing is still running as far as I know, Clark.
Well, that's an interesting curiosity, but the practicality of what? Someone's going to get a C-QUAM receiver for ham? And think about with the QR, QSB and QRM and everything else, it would sound like hell.
Yeah. You're talking about receivers and all. I don't know if you know about Chrysler and Generous Motors had numerous receivers that had C-QUAM. I'm sure you know this. And the GM ones, you can go on eBay and you can get one. If you get like a late, I don't know about 85, but 86, 7, or 8, like a Camaro, or a high-end, like a Cadillac, in-dash receiver. You know, there's probably 50,000 of them somewhere. They all have compatible quadrature modulation detectors in them, and they work. You want to put one on the ham band, you put a goon set converter in front of it. They were very popular in the 50s. And you can make your AM broadcast receiver receive ham bands with that. And you can listen to C-QUAM.
All right, and so the next thing, which is very important, is content. What's he doing which is actually stereo on ham radio?
See, this is the problem, Clark. You see, you've been following, and it's true. No matter what the hardware, no matter what your antenna is, no matter what your transmitter is, you can be perfect. You can have everything working right. You can have voice training. You know, you can take vitamins. But if your content sucks, you're dead. You got me.
Hey, can I ask you guys a question?